Now, who are we? NNNCo, as mentioned by Olivia, we are a 100% IoT business. We were established for the purpose of being a national operator, now actually more like with some global presence in multiple continents, but we are designed to be an IoT operator. We're not there to deliver other types of services, which makes us very, very focused in our market. We are focused primarily on the utility space and the enterprise space, and of course that means cities and the other organisations which fit into that scope. We specifically developed a platform, which I'll go into very briefly in a minute, to allow the aggregation of data, which I think LoRaWAN enables very, very perfectly. And of course, we now have a global presence with, we're in 16 countries, we're in 3 continents now, and growing at an exponential rate in terms of our coverage locations. I'm not saying we've got coverage in 16 countries, but we have isolated networks in each one of those locations. And that's another one of the benefits of LoRaWAN in terms of its global infrastructure. A little bit more about us, and the thing that I wanted to highlight primarily is we built something which I think is key to the success of LoRaWAN, and we decided that it was important for us as an operator who deals with many organisations, and each organisation has many use cases. We built a data aggregation type platform which specifically allows us to deliver and develop solutions in a really cohesive, standardised data model way, and I believe that's been key to part of our success. I'm going to get into the utility space now, and NNNCo has been quite fortunate in actually servicing both power and water utilities in Australia and increasingly overseas. Some of the quick areas that we're seeing significant interest in right now is the types of solutions we're looking at for power utilities is transformer monitoring, high voltage and low voltage line fault detection, conductor down, which is an incredibly difficult and challenging thing which LoRaWAN makes itself enables very, very well. Low conductors, so where you've got sagging conductors due to heat or other conditions due to pole tilt and these types of things. Very important, particularly in the areas like Australia where one electricity line which starts to sag might touch a tree which starts a wildfire which causes massive problems all over the world, but particularly in places like Australia and in the United States. Pole tilt solutions, distributed energy resource management systems, the management of solar installations and how that is affecting the grid itself and being able to manage and control those, and of course safety and tracking type installations. But I'm going to focus on a couple of specific use cases because I think they have particular relevance and they're actually interesting. This is some work that we're doing in Australia at the moment with Horizon Power, which for people who don't know it, they're actually they have a very small customer base over a massive geography, 2.4 million square kilometres. They're running a distribution network out there, and many of their services actually are run on full-time petrol generators, believe it or not, over very remote locations. So for them to go out in the world and actually service some of these lines, it's incredibly expensive. So knowing where there's a fault becomes critical to their operation. So we've got this product that we have been working on for quite some time with a partner company out of Australia. And it's actually for both line monitoring, fault detection, power quality, and also conductor height. So it measures the height of the conductor above ground. It detects the actual quality of the source of the power itself. It can actually determine where there's been some sort of a phase shift between the phases which are being delivered, another incredibly important technical element for a transmission company to understand. And of course, all of this is done by harvesting the power from the line itself. So it's a Class C, it's actually, this particular device is a hybrid Class C, Class A device, but it leverages the harvesting power from the transmission line, so there's no need for a battery. It's got a little solar panel built into the device to increase coverage if the power, if the power in the line is quite low, and in some cases in remote locations that can happen quite often, and therefore provides the utility with the ability to understand the quality of the power, whether they have a line down situation or whether indeed they've got a sagging line, all in the one device and empowered all by LoRaWAN. Incredibly powerful solution. This other one here, this is a really super important issue for any power utility, and it's this conductor down problem. I don't know if anyone here is from the power utility space or has much exposure or experience in it, but just a very quick problem statement. In all transmission networks, the upstream transformers have a lot of power traversing through them, and while they're live, there's a lot of information being gathered to the back at the head end system. If you get a conductor down at the upstream transformer end, you'll get a high current flow to the ground. You'll see here you've got a line sitting on the ground, that's on the load end of the service. But if it falls at the other end, you've got a high amount of current flowing, and the head end system understands there's a fault. It gets it. And it says, great, we've got a fault at this transformer, go and do something about it. But if that line down happens at the load side, in other words, downstream from the main source of power, you still get current flow because you've got backflow. It's still at 11 kV or 33 kV or 115, but the current flowing might only be 200 milliamps. That's not enough to trigger the systems at the head end, but that line is now sitting on the ground. Any person who touches it, any dog who touches it, any car that goes over it is immediately electrocuted. And there is no way to know that that system is off. Now, this is a global problem. And this partner company that we're working with today has come up with a solution on the conductor down algorithm. It uses a combination of sensors which are located at transformers, and those sensors can detect through a relationship between the sensors back in a head end system delivered as part of the solution, which allows them to say with a over 98% accuracy where there is a load side transformer fault or conductor down, and be able to deploy people out to go and rectify that before someone actually has an injury. Now, why is LoRaWAN good for this? Because again, the battery life is more significant with LoRaWAN than any other type of communications technology. It can run in Class C, so it's always available for operation. It runs a supercapacitor in the event of there being a power fault, and that allows you to keep that system up and running long enough to really be able to give meaningful information back to the head end system. Now quickly on to the NNNCo and the water utility space. We have been very successful in this space here in Australia, and actually again, the real reason why LoRaWAN works is we'll come up to in a minute, but some of the areas we've been working on: pulse logging for water metering where you've got retrospective builds, water metering enablement underground again, pressure relief valve systems, very important use case for water utilities, manhole covers to determine when a manhole cover is open or shut, leak and flow, and of course environmental and water quality. I'm going to quickly scurry through these. I know, Olivia, we're running out of time. The Gold Coast City Council's been a big customer of NNNCo for a long time. Many people know that. Our success there has been primarily around the early leak detection via pulse loggers attached to existing water meters. So at a very low cost, they've been able to actually literally save millions of litres of water as a result of just being able to detect early when there is a leak going on for a particular customer. So it's been an incredibly successful rollout for them. This one here, I'm not going to go into the technical details, very happy to talk about it later on with anyone at the back, but in effect, where there's a high pressure system at one end feeding into a low pressure downstream system, imagine a big pipe pushing into little pipes. If that power isn't equalised for the downstream applications, you end up popping hot water meter systems, and you run taps and you pop taps and all sorts of weird things happen. So they run these things called pressure relief valves, which are reticulated through the system, and all that we're really doing here is with a single device, 2 pressure sensors, equalising and monitoring the pressure of the system, and then informing the head end when there's a failure or a fault in that particular pressure relief valve. That enables the water utility to distribute personnel out to the site, take care of that problem before they start getting customer complaints. So I'm not going to go through all of these, but the big thing that is why LoRaWAN for utilities is in all of those electricity use cases I mentioned before. In each case, we are harvesting the existing power from the network. You can't do that with an NB-IoT device. There's just too much power required to harvest in a non-invasive way. In other words, we're just using current transformers. So you can't do that because you need too much power to do that with an NB-IoT type device. So LoRaWAN is uniquely positioned to service something where you need to harvest energy from an external source. And of course, in the water space, we talked, couple of the other speakers talked about 8 years, 10 years. I know for a fact that these infrastructure providers, utilities, they think in decades. They don't think in 2 years, 3 years. So we have to be thinking as an industry of how we actually deliver these services with decades in mind, keeping truck rolls down, keeping operational costs down. That means we need very highly reliable and available devices, and the communications needs to be the same. I'll leave that for now. Back over to you, Olivier.
Right. Thank you, Tony.